Hello students, welcome to the next video lecture on casting defects.
What is casting? Casting defect. So it is defined as those characteristics that create a deficiency or imperfection to the quality specification imposed by design or service requirement. So a thing which always creates some deficiency or improper application or such kind of a thing will be termed as a defect. So it won't meet the quality specifications imposed by the design or required services. So this defect will always reduce the total output and also increases the production cost. So nowadays with the modern foundries will also face 20% of rejection rate, which in turns increases the production cost. So this defects can be classified into four types. So namely surface defect. Surface defects is nothing but visible, the defect which is visible on the surface including incorrect shape, size, flashes or surface finish. So the next kind of a defect is nothing but the internal defects. Though this kind of a defect is not visible to the human eye, so usually it will present interior to the casting. So how this kind of a defects can be identified means usually inspecting using NDT tool. NDT is nothing but a non-destructive tool. In your higher semester, you will come to know about what is NDT. And next is incorrect chemical composition. So this is happened due to the formation of undesired foreign materials like slags or any impurities or something which was come from the dyes. So it will create the incorrect chemical composition. And finally, unsatisfactory mechanical properties. Due to all these three defects, the proper mechanical property won't be achieved by the final casting part. So that is the final defects. So these are the list of casting defects. We shall see one by one. The first and foremost is shrinkages. This is commonly happen defects in all the casting process. So you know what is shrinkages. There will be a depression after the casting process or solidification is completed. So just see this. So this is the desired part we supposed to cast. After the solidification, there will be some dip, right? So like here. So this is generally called as a shrinkages. This is happened due to improper solidification, incorrect pouring temperature, faulty gating runner and riser systems. So this can be avoided by providing proper solidification, pouring of molten material in the correct temperature. Next kind of defect is blowholes or open holes. This is nothing but there will be some holes which was happened in the casting like this, right? It will be, if the holes is in the interior, that is called as a blowhole. When it is on the surface, it is called as an open hole. This is always happened due to the gas which was developed while pouring the molten material, which cannot be come out of the mold cavity. So this is caused due to excess moisture in the sand, hard ramming and improper venting. So this can be avoided by controlling the moisture content in the sand, properly ram the mold and provide proper venting systems in the mold cavity. Next one is pinholes. So pinholes is nothing but the porosity or a tiny holes which is about 2 mm of a diameter, which is usually found at the upper part, right? So we know that this is the drag, right? This is the cope. So cope is the upper part. So usually such kind of defects will be always happen at the upper part due to poorly vented things. So this is caused by excessive moisture content in the mold sand and inadequate gas permeability of a molding. So usually all kind of holes or porosities happen due to the excess moisture in the sand and also inadequate gas permeability of a mold. Whenever we can increases the permeability of a mold, we can avoid this pinholes and also use a proper moisture content of a mold sand. And swelling is nothing but the enlargement of a mold cavity because of the molten pressure. We know that we are going to pour the molten material in very high temperature, so that will create some pressure inside the mold cavity. So this defects will happen by enlargement of a part. For an example, we supposed to have a part like this. So this defect is nothing but it will be enlarged like this. So you supposed to have a part like this, but it will be enlarged like this. You can able to see here. So this is caused due to soft ramming or quick pouring of your molten material. So this can be avoided by ram properly and pouring at a correct velocity. And next one is hotspot is nothing but in your total casting, so in some portion alone it will be very hard, right? So our accumulation of a particle will be very higher like this, right? So this is happen due to by a rapid cooling of a material and pouring at a lower temperature. So you should maintain the molten material temperature very constantly. So this can be avoided by pouring at a uniform cooling rate and pour at a correct temperature. And the next important defect is misrun. So what is misrun? Well, the molten material solidifies before completely filling into the mold cavity, right? So if you are pouring a molten material into the mold cavity, it has to fill on the total surface, right? So if suppose it filled only this surface and leave this as a vacuum, you will have such kind of a misrun defect, right? So this happens due to the low temperature of the molten metal, which decreases the fluidity. So you have to maintain proper temperature while pouring the molten material inside the mold cavity. And too thin section and improper gating system is also the another cause for this misrun. So how we can avoid this is increasing the pouring temperature of the molten metal, increase the fluidity, and also providing a proper gating system, and the thin sections can be avoided to avoid this kind of a misrun. And run out is nothing but there is a fault in a mold or sand mold, you can able to have such kind of a defects. So this is happen due to fault molding, there is some leakages or something else, and improper parting line. So improper parting line between the core and the drag, and improper gating system will also have the run out. So modifying these things, you can able to avoid such kind of a defect. So cracks. So as a shrinkage, crack is a common defect which was happen in all type of a casting process. So crack is nothing but a small defects which was happen over the surfaces or the two parting lines. So this is happened due to the sharp corners. You can able to see this is the sharp corners, and the improper solidification will also have such kind of cracks. Improper solidification means the temperature variation will also create some this cracks. So providing some good taper or round corners will also avoid the cracks, and a proper solidification system also we can able to avoid the cracks. And the next one is shift. As you know, in the pattern usually we will use cope and drag pattern. So the pattern, the split pip pattern, one piece you will keep in the cope and another piece you will keep in the drag. Whenever you cannot match that cope and drag patterns properly, you can able to have such kind of a defects. So this is happen due to mismatching of a casting sections. And whenever you use loose dowel pins in the pattern, you can able to have such kind of a shift in the patterns, and misalignment of a molding boxes will also have create some shift in the casted part. So usually we should have a tightened dowel pins in the pattern, and also alignment of a mold box should be proper before pouring the molten material. And the next one is inclusion. As the name implies, there will be some foreign particles or any other slags will be incorporated in the final casting. So this is caused due to low grade of molding sand and improper scheming. Scheming is nothing but after creating the mold material into a liquid state, some slags or impurities will be floated over the surfaces. We have to remove that slag or impures in the molten material. After that only we have to pour inside the mold cavity. If we forgot to remove that, that will be create some inclusion in the final casting. So this can be avoided by using correct grade of a molding sand and also using some proper scheming. And blister is also a type of a blowholes porosity kind of a defects. So this is a scare covered by a thin layer of a metals. You can able to see this is the blister. So this is happened usually by improper pouring temperature. So you can able to see there are a lot of defects which was happened due to improper pouring temperature. So that you have to know that there should be a proper temperature before pouring into the molten material, right? So also insufficient molten material. So the volume is 1 cubic centimeter means then you should pour 1 cubic centimeter molten material inside the cavity. If there is some insufficient or was insufficient of a molten material, this kind of a blister will be happen. So this can be avoided by pouring at a correct temperature and also using the sufficient molten material inside the mold.